Hello everyone. I'm with one more question regarding JE kinematics problems as like a problem number 8. You can see this question here. A ball starts falling with zero initial velocity onto a smooth inclined plane. This plane forms an angle theta with the horizontal. Okay. Having fallen the distance h, ball rebounds elastically of the inclined plane. At what distance from the impact point will be a ball rebound for the second time? The answer for this you will get as 8h sin theta. Let me draw one clear diagram for representing the given question, and then I explain you the way how it is better to approach. See, if this is like it's a solution, if this is the inclined plane, see this is the inclined plane, angle of inclination as mentioned in the question paper, this is the theta. See, as they have not mentioned about the whether the wedge is moving or not, by default we need to consider it is like a fixed wedge, and a ball has fallen like a freely falling body with zero velocity onto the inclined plane vertically downward. Okay, see, the ball actually has dropped from a height of small h according to the question, right? Having fallen h distance downward, this ball is going to collide over this spot. Done. Now immediately, as you can notice that this projectile or this particle hitting with this inclined surface, there is a chance of having a collision between ball and the inclined surface. So whenever collision is going to happen over the a particular spot, it is advisable to draw line of impact first, isn't it? So we do this work generally in collisions. Immediately whenever there is a happening collision between two objects, at the common contact surface we draw a line of impact, imaginary line. Now this particle at this instant of hitting, say it has some v speed, and obviously that will be a downward vector, and the value of v will be obviously root of 2gh, because it's a freely falling body. After traveling h amount of distance, everyone can notice that it would be v equal root of 2gh. And I have slided this vector v, and this will be, this vector, vertical downward vector with this red dotted line would be making angle theta, angle which is equal to this theta, angle of inclination will be represented here, and with the geometry everyone can prove it. See, it's like a minimal information. So this is a v, and I can resolve this into two components, v cos theta and v sin theta. Okay, now you can see here this component is along the line of impact, this component is parallel to the line of impact, so this component will be unaffected, and along the line of impact whichever the velocity is there, that will be influenced in the collision process. So immediately when it bounces off from the inclined plane, this vector abruptly will be shifted to the opposite direction. As it is a perfectly elastic collision in the question it is mentioned, so it also will be v cos theta itself. Okay, see, this is the impact point, this is the collision point, and from this collision point, if you observe, it has two velocity vectors or two velocity components perpendicular to each other, and hence along the resultant velocity direction it will take off from this spot, and again it follows its own parabolic path. Again it may hit somewhere here, okay, and then it can have the chance for bouncing second time at this spot onwards. And our question is what here? From the impact point, say this is A, from the impact point to second time impact, second time bouncing point, say this is B, say this spot is B. Okay, from A to B, whatever the distance is there, that we need to find, right? So is it not like our range on the inclined plane? See, it's like a well-known fact of concept of finding the range of the projectile on an inclined plane. So to do this problem, let me create the useful Cartesian plane x and y parallel to, x-axis parallel to inclined plane. Okay, I'm taking the analysis with respect to this plane, So I need the acceleration vectors which influence the projectile according to the selected plane. So as you know, G is a vertical downward vector. See, actual G you can represent anywhere. For easy resolution purpose, let me represent here itself. As it is making here 90 minus theta, you can get here G cos of 90 minus theta, G sin theta. Here G sin of 90 minus theta, G cos theta. I mean here what? Parallel to the inclined plane, the value of acceleration will be G sin theta. Perpendicular to the inclined plane, okay, perpendicular to the inclined plane, it will be G cos theta. Okay, now see here, let us analyze, because you want this distance, it's nothing but a range. First of all, how much time it takes to come from A to B, or I can say what is the time of flight. See, we know that in the time of flight time, vertical displacement is 0, right? This is what the very important point should be revised every time when we require to calculate the time of flight. So vertical displacement is 0. So I switch my focus completely on vertical analysis. Okay, vertical analysis, I mean here what? Y-axis analysis. So the initial y-axis velocity is what? V cos theta. Okay, and acceleration along y-axis is downward, so it will be under retardation. So Ay will be your G cos theta. So as you got to know about the concept called displacement along y-axis 0, if you take second equation, Sy is equal to u by t plus half a by t square. If t is capital T, then vertical displacement is 0. So I can say here 0 is equal to V cos theta minus half G cos theta. I'm so sorry, here t is there, right? Into t, capital T, minus half G cos theta t square. Okay, so V cos theta into t equals to half G cos theta t square. One t will be cancelled. So t you got as 2V cos theta by G cos theta, where you can get t as 2V by G. Okay, so you got to know about the time of flight of this projectile on the inclined plane. And in this capital T time, the horizontal displacement is what we call as range. So while calculating horizontal displacement of the projectile on the inclined plane, do remember it has a horizontal acceleration. Velocity direction and acceleration direction are in same direction, so it will be increasing its speed. So it is under acceleration along x-axis. You need to use, or I can go for saying horizontal analysis. Okay, horizontal analysis purpose, it will be nothing but x-axis analysis purpose. I will notice that let me notice that ux is what? Initially it starts with velocity v sin theta. Okay, here it is v sin theta, right? This value is initial horizontal velocity v sin theta, and you know ax is g sin theta. Okay, ax is g sine theta. Obviously I go for, if t equal to capital T, x is equal to range. Therefore Sx is equal to uxt plus half axt square, second equation of motion along x axis if you apply. Okay, in this place if I write capital R, ux is v sine theta into t is capital T plus half ax value is what, g sine theta into t square. So range what I got here is v sine theta into t value what you got just now, 2v by g, isn't it? Here you can see 2v by g. So 2v by g plus half g sine theta into same capital T v square. So it will become 4v square by g square, right? So capital R will be equivalent to 2v square sine theta by g plus, here you will get 1 g cancelled out, 1 2 1s are 2 2s are, so again it will get 2v square sine theta by g, or I can get here R is equal to 4v square sine theta by g. Okay, this is the value of capital R. And see here, let me go for the initial diagram page for the sake of knowing what is actually the v value. See, in the initial diagram you know that as v is nothing but the velocity of the freely falling body exactly when it hits the inclined plane for the first time. That already we know that v equal to root of 2gh. So v square will be 2gh now. So here in this place of value of v square you can place that. So 4 into v square value is 2gh, okay, sine theta by g. Again small g will be cancelled. So range is equal to 8h sine theta. 8h sine theta as our answer. This is nothing but range of the projectile on the inclined plane, as well as I can say it is nothing but the distance between first impact point and the second time impact point where it starts bouncing one more time onwards. Okay, hope so you understood this concept very well with this explanation. Thank you.